Hello, welcome to my new film on YouTube where I will present you balance between equations, one of the most basic but the most important properties of algebra that was invented by one of the greatest mathematicians in all history, Muhammad al-Khwarizmi, that lived in 9th century. First of all, I want to present you his way of thinking that allowed him to view equations in a different form, because before him the people mostly, whenever you see an equation that is 3x equals 15, they thought about those equations, the solutions to those equations in a substitute way. So they would substitute 1, 2, 3, 4, 5 and check out what will fit. Of course, there were some ways to quicken the way, but there wasn't any quick way to write it down. The first method to actually visualize the variables, the numbers, it wasn't written in this way. It was only introduced in Europe in 15th century. So Muhammad al-Khwarizmi really revolutionized it. Yes, and he imagined that equations were like balance of weights. We have on a scale two different numbers, two different variables that we will represent by, for example, adding a 15 kilogram bag of flour. On the second part, to balance the weight, we need to have something with the same weight, the same value. So we will, for example, have, I don't know, maybe a very good bread that was made in the morning. So we get 15 loaves of bread, each worth 1 kilo, and it will balance the weight. So, what can we realize from this scale? We can realize that whenever we want to change these equations in any way, we need to add to both sides. Whenever we want to add a variable with the weight of 2, for example, 2 kilograms of peanuts, we need to add on the other side, because otherwise the scale would be unbalanced. On the other side we would add, for example, apples, a very expensive commodity in Arabian Empire. So we get first visualization of this product. But now what we want to introduce is the way of thinking. Whenever you see any equations, 3x plus 4 equals x minus 2, so we already introduced the property of adding to the both sides as in the scale, but it also translates to multiplying. For example, you have 17 kilos of weight here and you have 17 here. If you multiply by 2 and also here by 2, you will get 34. So now, what about dividing? So when you want to divide, you actually are multiplying by a reverse. Do you remember this kind of property from your school, where you, for every rational number, there's always a reverse of this number. So for example, you get 2, and the reverse of this number is 1 over the original number. And when you multiply those numbers both together, you get 1. For any kind of number that you can imagine, any rational number that can be described as p over q, so a fraction, there is a reverse of this number. And because of this property, dividing is actually multiplying. So whenever you divide in this way, you multiply by 1 over 2, a half of this number. So imagine you have a scale. On this scale you get 3x plus 4 on the left side, and on the right side you have yx minus 2. And we know that something isn't right, because it seems this side will be much more weightier, much more robust. So what we want to first do is to, first of all, subtract all kinds of variables from the right side. and then when we subtract and we transfer to other side, we will transfer the numbers to the right side and solve these equations. You can imagine it as a scale being unbalanced. What we want is to bring the balance to the scale, and when the balance is brought, we will find the x value. Also, a very important quality of this equation is that whenever you transfer a number here to the right side, you are actually reversing the plus sign to minus. You can imagine it as something the scale being unbalanced, having 4 more here, so we get 21 here, and 17. When we want to bring this to balance, we are actually subtracting 4 from the left side. And when we subtract and add here 4, we will transfer this number, but it's an opposite number. Opposite number is a number that has a different plus minus sign. So first of all, we want to bring our variables to the left side. 3x minus x, because we are actually subtracting x from both sides. So we get 3x minus x plus 4 equals minus 2, because we subtracted. But it's a much more quicker way and much more efficient if you think about this as transferring the variables, picking one apple and transferring to other side, picking a bag of flour to the other side, not as subtracting from both sides of equations, because it can be tremendously wasteful. Okay, so we get variables on the left side, we transfer 4, we pick it up, we transfer to the right side, and we get that 2x equals minus 2 minus 4. Okay, so we get that 2x equals minus 6, minus 2, minus 4, 2 vectors. First vector on the number line is pointed from 0 to minus 2, and the second vector is pointed towards minus 4. So we get minus 3, minus 4, minus 5, minus 6. And look at this. Vector is pointing at a direction of minus 2. And we also get a second vector that is equal to minus 4 here. So when we add those vector, look, this vector to this vector from the minus 2, we get one big vector to minus 6. This is why when you subtract a negative number with another negative number, you actually are adding them, because you are going on the left side of the number line. So what we have now is 2x equals minus 6. What we want now is to multiply by the reverse of 2. So what we do? We multiply by 1 over 2, the opposite number. 1 over 2 here, both sides of equation. This is the same as actually imagine the scale, and we actually are cutting the ingredients on both sides and throwing them to the trash, throwing them on the left and the right side, and we have x equals minus 3. Thank you very much for this lesson.